This video is a demonstration of one of Maxwell's equations, Faraday's law, by designing, building, and testing a dynamic microphone. Faraday's law describes the relationship when there is a change in magnetic flux over time, an electric field is created. When a conductor is present, this induced electric field can induce a voltage, commonly referred to as electromotive force. Lenz's law describes the direction of currents that which would create a magnetic field opposing the original magnetic field. A dynamic microphone is a direct application of Faraday's law. They are constructed with a permanent magnet, a coil of wire, a diaphragm, and a housing to secure all these components. Dynamic microphones work using a permanent magnet to set up a magnetic field and therefore a magnetic flux. A coil of conductive wire is suspended near the magnet, attached to a diaphragm. When an active acoustic source is present, sound waves excite the diaphragm, creating a vibration in the coil relative to the magnet. Faraday's law states that this motion of the coil relative to the stationary magnet induces an electric field, which in turn induces a voltage in the wire coil. This induced voltage causes current to flow in a direction described by Lenz's law. Due to the oscillating motion of the coil, the voltage sign will flip with each change in direction of the coil. This creates an alternating current that corresponds to the sound wave. Here are the components that will be used to build a dynamic microphone for demonstration. The magnet wire will be used to create a conductive coil, paper for the diaphragm, a permanent magnet, housing, and a 3.5mm jack. First, we are going to coil the wire. We're going to build 2 coils total, one with few turns and one with significantly more turns. This will allow us to verify a component of Faraday's law by comparing the induced current when creating a vibration in the coil. Next, we're going to install the coil onto the diaphragm using hot glue. Finally, we're going to install the coil and diaphragm, along with a magnet, into the microphone housing. Now that the microphones have been built, we are going to perform a functional check by using the 3.5mm jack to plug into a computer, record audio, and listen for the output. First, we will use the microphone with a larger number of turns on the coil. Testing, microphone testing. Testing, microphone testing. Next, we will perform the functional check on the microphone that uses a coil with significantly less turns. Testing. Hello. Testing. Hello. This test proved both microphones are functional without any appreciable difference in sound. Now we are going to take measurements on the alternating current generated by exciting the diaphragm of each microphone. The peak values for each microphone are listed. As expected, the microphone with a larger number of turns than the coil produced a greater current. This is because the induced voltage is proportional to the number of turns in the coil.